This is section 7.6, operations with functions. We have one vocab term this time, and it's a function. And a function is an equation that allows a value of x to produce a value of y. So if you have your equation where you have f of x equals, that's usually your function where that value of x produces a value of y. Some very important concepts we have f of x plus g of x is the same thing as f plus g of x. So it could be written the same way, but you're still adding your functions together. If you have f of x minus g of x, it's the same thing as f minus g of x. F of x times g of x is the same thing as f times g of x. And f of x divided by g of x is the same thing as f divided by g of x. So that's all your green, operations with functions. And then in purple, we have composition of functions. So these two mean the same thing. This says f of g of x, and this says f of g of x. And you see each of these when we do composition of functions. The difference between this and multiplication, and this is going to be an open circle, like an open O, whereas this is always filled in as your multiplication sign. So we have our four operations, and then we have two ways to write composition of functions. So our first example says let f of x equal 5x plus 2 and g of x equal x squared, and we want to find f of x plus g of x. So we write the f of x equation first, because it's first here, you have to pay attention to the order. F of x is first, so I'm going to write f of x first, 5x plus 2, plus g of x, which is x squared, and I'm going to add them together, 5x plus 2 plus x squared, and you would combine like terms. In this case, we don't have any like terms, but we do want to write them in order for the polynomial. So you have x squared plus 5x plus 2 as your final answer. My second one up here says g of x minus f of x. So because I start with g of x, I want to start with g of x as x squared minus 5x plus 2. And anytime you're subtracting, you have to make sure you distribute this negative sign. So I have x squared minus 5x and minus 2, because that negative goes to this 5x and it goes to that 2. So my final answer is going to be x squared minus 5x minus 2. When you're multiplying, now this says f times f of x. So that means I have f, which is 5x plus 2, times f, which is 5x plus 2. So I'm multiplying them together. Again, pay attention to which functions it's telling you to use. So because it says f times f, you want to multiply that by itself. And when you have two functions like this, you want to FOIL to multiply. So I have 5x times 5x gives me 25x squared. My inside terms, 2 times 5 gives me a 10. 5 times 2 gives me a 10. When I add them together, I get 20x. And 2 times 2 is 4. So my final answer here, when I FOIL and multiply that all out, is 25x squared plus 20x plus 4. And last, we have division, g of x over f of x. So I have g of x first, which is my x squared goes in the numerator, over f of x is in the denominator, so that's 5x plus 2. So my final answer here is going to be x squared over 5x plus 2, but you do have to determine what value can't be in your denominator. So when you're dividing, you always want to make sure to state the restrictions from the domain. So you set that denominator equal to 0. So I have 5x plus 2 equals 0, or I subtract 2 and divide by 5, and I get that x equals negative 2/5. So x can't be negative 2/5. So my domain would say negative infinity to 2/5, or negative 2/5, union negative 2/5 to positive infinity. And then my last few examples are on composition of functions. So I have let f of x equal 2x squared minus 1, and g of x equal x plus 3. So if I want to find f of g of 3, for composition, you're always working from the inside out. So I'm going to find g of 3 by plugging 3 into the equation for g. So 3 goes into my equation for g, and I end up with 3 plus 3. So g of 3 is 3 plus 3, which is 6. Then I take this number, the number I got from finding g of 3, and plug it into f, the outer equation. So that's f of 6. So I have 2 times 6 squared minus 1. And 2 times 6 squared minus 1, this is 36. Times 2 is 72, minus 1 is 71. And that's your final answer. So working from the inside out, I have g of 3 plugging in to get 6, and then I have that f of 6 to get my final answer. And my second equation says find g of f of x. So instead of a number this time, we have a variable, which means we're going to get an equation answer instead of a number answer. So I have f of x is on the inside, so I'm going to take this f of x and put it in for the x in the g of x equation. So I have g of 2x squared minus 1, which means instead of this x, I'm going to put in 2x squared minus 1, and then the plus 3 carries along. So I have 2x squared minus 1 plus 3, and combining like terms, I get 2x squared plus 2. If I were to find f of g of x, I want to take my g of x equation and then put it in for x in my f of x equation. So I would have 2, and then I'd have x plus 3 in for x squared minus 1. And anytime you have an x plus 3 or a function squared, you want to write that twice, and you want to distribute to FOIL it out. So I have 2 times x plus 3 times x plus 3 minus 1. So I have 2 times x squared plus 6x plus 9 minus 1. Distributing the 2, I have 2x squared plus 12x plus 18 minus 1. And combining my like terms last, I have 2x squared plus 12x plus 17.